Okay, so next step is to solve for the tension, work done by tension, right? So let's write down the equation for the tension first. So it's the work done by tension, and that is T is the force dotted with D. And that gives us TD cosine theta, right? So I really want you to be able to do this algebra first. The dot product gives you cosine function. Look at the notations that I used, arrows. Now that I dropped those arrows because they mean these are only the magnitudes. So if I want to solve for the work done by the tension, I need T, D, and cosine theta. So I know that theta, looking at my free body diagram and the displacement, I already know that they point the same direction, T and D, so the angle between them is 0. But I don't know what tension is, so that's the problem, right? Let's just kind of, if I want to find the work done, I need to figure this first. How do you solve for a force? What do you do? Think about that. We are going to use second law, right? So we said that the tension is along the y direction, so we are going to use sum of Fy equals to MAY. And what is the sum of Fy? So tension is upward, and we chose upward to be positive y, it's positive T. And the weight force is downward. T minus W is the net force. And that's equal to mass times acceleration. There's only one acceleration, so I'm kind of dropping that y to a, and I will plug the numbers later. What is T? Putting W on the other side, and it is in the form of mg. So it becomes ma plus mg. And as you know, I don't want to do extra calculations, so I'm gonna factor out m, and the tension becomes the mass of the object is 75 kilograms, and A is 1.5. It's positive upward, right? And what do I put for G? Is it negative? Remember, G is never negative, okay? G is has a value, it's a scalar quantity, and it is 9.81. So you always put positive 9.81 meters per second square for G, okay? That might look weird, but remember that G is the acceleration of the gravity is taking downward. But how do you know that? This is where we did this, okay? So it's negative W because it was downward, because of that gravitational pull being downward. So after that, when you put that on the right side, it becomes positive. So what? Just like follow it and make sure carry it out correctly. And this gives me the value of 840. Okay, 848 newtons. Okay, so that's the tension force. Once I get that tension force, now I know what to plug it in for tension. And I'm gonna go back to the work definition. Work done by tension is TD cosine theta. T is 848 newtons. D is 10 meters. Theta is simply 0. So this becomes 1, positive 1. And the work done by the tension becomes 8480 newtons times meters is joules. So we're going to use J, capital J, as joules. You can also write this in terms of 8.48 kilojoules, right? Divide by 1000 becomes kilo. But joules is the SI unit, kilojoules is not. So if it is given as in kilojoules, you have to convert it to joules first. So that is the work done by the tension. As we discussed already, we expect, and I want to take a note here, this is the tension force, right? We expect this to be more than the weight force, which is mg. So we expect this to be more than that. That means the work done by the weight force is going to be higher than this value. and I'm gonna show the second part in another video.